Okay, our last trig identities are this product to sum and sum to product. So we're going to start with the product to sum. So remember, product is when we multiply two trig ratios together, and a sum is, when we add or subtract them. All right, so we'll write these formulas down. We are going to start with multiplying two ratios together, and then, this unit's all about how we can rewrite different trig ratios. So we can rewrite these by adding or subtracting two trig ratios together. Okay. So product to sum, I am multiplying two ratios together. So I'm going to call 5x A and 4x B. Okay. I know that the cosine of A times the sine of B is equal to 1/2 times the sine of A plus B minus the sine of A minus B. So I'm just going to go ahead and rewrite these. The cosine of 5x times the sine of 4x is equal to 1/2 times the sine of A, which is 5x plus 4x, minus the sine of 5x minus 4x. Okay, so the cosine of 5x times the sine of 4x is equal to 1/2 times the sine of 9x minus the sine of x. And we are done with that one. All right, let's look at number 2. Okay, number 2 is an example of a sum to product. So I'm adding two trig ratios together. When I rewrite them, I get the product of two trig ratios. So we're going to call this angle A and angle B. From the formulas above, I can see that the cosine of A plus the cosine of B is equal to 2 times the cosine of A plus B over 2, so like averaged, the cosine of A minus B over 2. Okay, so let's do this. The cosine of 195 degrees plus the cosine of 105 degrees is equal to 2 times the cosine of 195 plus 105 degrees all over 2 plus, times, since I'm moving into a product, 195 degrees minus 105 degrees all over 2. Okay, we simplify to give us 2 times the cosine of 150 degrees times the cosine of 45 degrees. And now we can evaluate this actually. So let's go to the side at 150. So 30-degree reference angle, the cosine would be negative root 3 over 2. So 2 times negative root 3 over 2 times the cosine of 45 is root 2 over 2. The 2's cancel, giving us negative square root 6 over 2. Okay. Lastly, let's verify algebraically that the right side is equal to the left side. So let's start with a more complicated side. I'm going to start with the right side. Okay, so the secant of 2 theta is equal to, I'm going to change this to 1 over cosine squared theta using the reciprocal identity over 2 minus 1 over cosine squared theta, again using the reciprocal identity. Since I have a fraction on the bottom, I think we need a common denominator. So let's multiply by cosine squared theta. This 2. So secant 2 theta is equal to 1 over cosine squared theta all over 2 cosine squared theta minus 1 all over cosine squared theta. I would like to not have dividing by fractions, so multiply by the reciprocal from the denominator, cosine squared theta over 2 cosine squared theta minus 1. See, everything from the bottom should cancel. And then my cosine squared thetas also cancel. So I get the secant of 2 theta is equal to 1 over 2 cosine squared theta minus 1. And I can remember from my double angle formulas that cosine of 2 theta is equal to 2 cosine squared theta minus 1. So I can replace this whole deal with cosine 2 theta. So secant 2 theta is equal to 1 over cosine 2 theta. And I remember that secant and cosine are reciprocals, so the right side is equal to secant 2 theta, and the left side is equal to secant 2 theta. And we're verified.